Myself is Risha, working as assistant professor in MBR College of Engineering and Technology. Today, we are going to discuss the topic of available energy, availability, and reversibility. Now, from second law of thermodynamics, we found that complete evaporation of heat is not into work. It is not possible in continuous process because of some amount of losses has been occurred when we are doing conversion of heat into work. And also have proved that by taking the Carnot cycle, and this Carnot cycle most efficiently producing work. And even if in the Carnot cycle the efficiency conversion can never be unity, and because of at least some losses, nearly it is a 99.99%, not like 100% give the efficiency. And the same thing, and also conversion of work energy conversion in corner cycle we see. At the same thing, the maximum theoretical work obtainable with respect to some data is determined. Okay, so now we are going to the new topic of available and unavailable energy. What is available energy? What is unavailable energy? Available energy is nothing but useful work. Useful work we called as available energy, and waste work is we called as the unavailable energy. So but first we look what it is mentioned. The energy content of a system can be divided into two parts. So one thing, the available energy, which under ideal conditions may be completely converted into work. So when we give the work, and when you give the energy, it will be completely converted into work. We call as the available energy. So when we call as unavailable energy, if you give some amount of energy to the system and it would not give the 100% of energy, it's some losses. That loss of energy we call as the unavailable energy. So the consider Q units of heat energy available at the temperature. Okay, so available part of energy can be obtained by assuming that the heat is supplied. So the assume of heat supplied in Carnot and an engine we call as available energy. So work obtained from Carnot engine. So work obtained from Carnot engine we will take in the form of T minus T naught by T into Q. We call as work in energy in the available part only. The quantity T naught by TQ in the available energy that we called as the quantity T naught by T into Q is the unavailable part in the TS diagram. These quantities can be represented as shown in the figure. So the term T naught is the ambient temperature. Hence, it can be concluded that the available and unavailable part of energy content of the system depends upon the ambient conditions. Well, we draw some diagrams, so it is easy to understand. So what is that? Here there is no any diagram. Okay, this is the diagram. So this is engine. This is a system that is nothing but engine, and this is lower. This is higher temperature. This we called as source, and this is we called as sink. Okay, right, sink, and here. The T naught is the ambient temperature. So here, when we run the engine, so it gives the work done. So when we get when we'll get work done, so when we supply amount of heat, that heat we called as available energy. So this we called as an available energy. Here rejected heat Q2. Here it is Q1. So that rejected heat we called as unavailable energy. Understand, students? Here the supply amount of heat we called as available energy. The rejected amount of heat we called as unavailable energy. So when we supply amount of heat, that gives available energy. So that the work done is T minus T naught by T into Q. That is the available energy. So here T naught by T is the unavailable part in the TS diagram, right? Okay. So next we go. And next we go to the, here this is the diagram, and next we go to the okay, and next we go to the reversible work. reversible work, and in a non-flow process. Non-flow process is nothing but it is not a closed system, it is an open system. So when we take a reversible work in non-flow process, so how it would like, from first of thermodynamics, q minus w, letting go q, total work is q minus w is equal to internal energy according to the first of thermodynamics. For second law of thermodynamics, for reversible processes, delta system universe is equal to, delta is nothing but change of entropy of universe, is nothing but entropy of system, change in entropy of system plus change of entropy of surroundings. Okay, where delta of system is nothing but S2 minus S1. So delta is surroundings, we will write as q, heat surroundings by temperature surroundings, is equal to minus of q system by T naught. So then after how should we like, so q system is equal to T naught into S2 minus S1. Because of this, we will write as, delta S of surroundings, that deltas of system, deltas of system is nothing but S2 minus S1. So finally we called as q system is equal to T naught into S2 minus S1. For q system is equal to that q system, we will substitute here 6.1. So finally we get the equation of T naught into S2 minus S1 minus W into U2 minus U1. Whatever, there is no any confusion. First of all, we will take the equation from first of thermodynamics, Q system minus W is equal to U2 minus U1. Okay, this Q system where we will get from second law of thermodynamics, we will take in the form of Q system is equal to T naught into S2 minus S1. This equation we will place here, this Q system. This Q system is nothing but T naught into S2 minus S1 minus W is equal to, this is U2 minus S1 is nothing but a change in internal energy. So finally the work done we called as W is equal to U2 minus U1 minus S1 minus S2. So since the process is reversible, W can be represented. So W reversible for U1 minus U1 minus T naught into S1 minus, for if it is a W can be represented in the form of reversible work done. So just we will replace S1 minus S1 with the T naught into S1 minus S1. So finally the work done of reversible is equal to U1 minus U2 minus T naught into S1 minus S1. So this is also the maximum work in the process. Okay, for a closed, this is for, this work done is for open system. This is we called as the maximum work in the process. And next we go for the work closed system. In this closed system, when undergoing change in volume, work done recognize the atmosphere. So the work done is equal to, this is for closed system is nothing but piston and cylinder. So P naught into V2 minus V1 because of closed system. But this work is not useful and is not a useful work. And W maximum useful is nothing but max work minus atmospheric work. So this is the atmospheric work. So finally, what is our maximum work? This is our maximum work. This is our maximum work. U1 minus U2. So this is our maximum work. So this is our maximum work. U1 minus U2 minus T naught into S1 minus S2. Atmospheric of work done of closed system is P naught into V1 minus V2 minus V1. So finally, we got the U1 minus U2 plus V naught into V1 minus V2 minus T naught into S1 minus S1. So this is our final equation. Next step, reversible work in a steady state control volume. So steady state control volume is nothing but steady flow energy equation for a control volume. Already we know that Q minus W dots with respect to time. So mass out H5 plus C square by 2 plus Z1, mass out minus mass in. So enthalpy, kinetic energy, this is potential energy. So out minus in. So this total equation we called as steady flow energy equation. And finally, we got the equation of m dot into h2 minus h1 plus c2 minus square minus c1 square by 2 plus g into z2 minus z1. Data are nothing but we called as datum. And what do we know from second law of thermodynamics? So delta S Urus is equal to delta S system plus surroundings. So because it is a steady flow, so the total entropy change of universe is equal to 0. So this is we called as control volume. So delta S CV is equal to, so this is 0. So m dot into S2 minus S1. So surrounding is delta S of surrounding is nothing but minus Q by D naught formula. So substitute, finally we get this is the Q dot is equal to T naught into M into S2 minus S1. So this is equation. And just what is the work done of reversible? M into H1 minus H2 minus T naught into S1 minus S2. We just replace that. We just place here only. So this is our equation. So this is our equation, and we call the we want the W reversible, and just find and just to place the what is the Q dot. So if you place the Q dot, and we got the W reversible for steady energy equation. So just this equation we will place that. So Q minus W, that Q dot is nothing but T naught into M dot into S2 minus S1. So just we place that. Finally we got the equation of W reversible is equal to M dot into H1 minus H2 by minus T naught into S1 minus S2, right? So in an open system, a fixed volume in space known as control volume. So the fixed volume in an open system we call it as the control volume is taken for analysis. Hence the atmospheric work term P naught into V1 minus V2 should not be considered. Therefore, W reversible is nothing but a W maximum useful. This is only for the open system, right? So what I want to mention that so every time that W the work done of reversible is nothing but work done useful work, that is my maximum work. Okay, and next availability. What is availability? Availability is nothing but the maximum useful work that can be obtained from the system, such that system comes to a dead state while exchanging heat only with the surroundings. So is called as availability. That is overall nothing but availability. Useful work called as the available energy. Hence, the term dead state means a state where the system in thermal and mechanical equilibrium with the sun. That is nothing but there is no any changes. That the thermal and mechanical both will become in the equilibrium state. That state we called as the dead state. So, if the dead state, how our availability in closed system. So, therefore, for a closed system, availability can be expressed as phi is equal to u minus u naught plus p naught into v minus v naught minus t naught into s minus n. So those terms are related for in dead state when the system in thermal in equilibrium, the equilibrium state, that state we called as the dead state with respect to surroundings. At that condition for closed system, what is the availability? So phi is equal to u minus u naught plus p naught into v minus v naught minus t naught into s minus s naught. So okay, next similarly for open system, availability for open system is nothing but h minus h naught minus t naught into s minus s naught. So there is a confusion here only, students. So for availability for closed system, when the system in dead state, so for closed system availability is nothing but phi, and psi we called as for open system. It is an availability for the system in dead state. Okay, understand? And next, if in a steady flow systems, the exit conditions are assumed to be in equilibrium with the surroundings. So we take the steady flow systems at the end, the exit conditions we assumed in equilibrium state with respect to surroundings. So the change in availability, how the availability change? Okay, when the exit state is equilibrium. So the change in availability of a system when it moves from one state to another. So for a closed system, so this understand, students, this is for closed system and this is open system for when it is in dead state. But here when flow states for steady flow process, only exit state is not initial state. When exit state is assumed as equilibrium state. Okay, so at that condition what is the change of availability for closed system? So for a closed system, phi1 minus phi2 is equal to u1 minus u2 plus p naught into v1 minus v2 minus t naught into s1 minus s2. Understand, friends? At the same thing here also for open system, that is the meaning of initial state is same for the exist state is equilibrium state. At that condition, what is the changes of availability for open system and closed system? Already we looked at the closed system. Now we look at the open system. So what is the open system for availability changes for initial state and exist state? And exist state we assume it as a equilibrium state. So at that conditions, the changes for an open system, xi1 minus xi2 is equal to h1 minus h2 minus t naught into s1 minus s2. So those it is the equation for open system when the condition of what the condition of existing system. Existing system is at equilibrium state. Equilibrium state, but initial state is not constant. Only our existing state is equilibrium condition. At that condition we have the we want the formula. What is the formula for availability? Is nothing but for open system. 7 minus it is equal to h1 minus h2 minus t naught into s1 minus s2. So that is the formula regarding the availability for difference of initial and exist state at the equilibrium condition. Now availability change involving heat exchange with reservoir. So consider a system undergoing a change of state while interacting with reservoir kept at TR, that is nothing but reservoir, and atmosphere at P naught and T naught. No net heat transfer to this. So how the net heat transfer? So this is our system, this is reservoir and this is atmosphere. This is our work and reversible. So finally we got what is the net. So that is nothing but Q R minus Q naught. So this is our QR. This is a QR minus Q naught we called as the Q net. So from first of thermodynamics, Q net minus W net is equal to U1 minus U2. And the same thing from second of thermodynamics, delta S reversible plus delta S atmosphere plus delta S system is equal to 0. So this is nothing but surrounding QR by TR plus Q naught by T naught plus for system S2 minus S1. So finally we are rearrange it, and negative sign here shows that heat is removed from the reservoir. So finally we got the Q naught. So net heat transfer is nothing but Q net minus Q net is equal to QR minus Q naught. So QR minus what is our Q naught? Our Q naught is here QR into T naught by TR plus T naught into S1 minus M. Just to substitute here, placed here. So finally we get QR minus QR, and finally we get the W reversible U1 minus U0, U1 minus U2 minus T naught into S1 minus S2 plus QR into T1 minus T naught by TR. So finally we got the maximum useful work. So U1 minus U2 plus P1 naught into V1 minus V2 minus T naught into S1 minus S2 plus QR into 1 minus T naught by T naught TR. This is our irreversibility. So above this is for how the heat exchange with reservoirs. So finally got this is an important equation. And next irreversibility. What is irreversibility? We obtain in an irreversible process will always be less than the reversible process, because of it is irreversible is an actual process. The difference is termed as irreversibility. That is the difference between the reversible work and actual work for a given change of system. Of a system is called as an irreversibility. So irreversibility, how it is mentioned that, so I we called as the irreversibility is equal to work done for reversible minus work done of actual. So irreversibility is nothing but the difference of work done for reversible minus work done of actual we called as irreversibility. So this is very important. This is very important formula. So the irreversibility is nothing but difference of work done reversible minus work done actual. So what is let a stationary closed system receiving Q kilojoule of heat is giving out work done kilojoule of work from first of thermodynamics. So Q minus W is nothing but U2 minus U1. We take W actual. So Q actual is equal to U1 minus U2 plus Q U1 minus U2. So we write because of reversible T naught into S2 S1 minus S2. So this is for W reversible, and just put it put it the equation in U1 minus U2 plus T naught into delta S system minus actual is nothing but this is, and finally this is our Q. Just place the Q, and U1 minus U2 minus W actual is minus W. So finally got T naught into delta S system minus Q, where Q is equal to minus of Q surroundings is equal to T naught into delta S. Finally we got the T naught into delta S universe. So finally what we got, the I is irreversibility is equal to T naught into delta S universe. So this is our equation. At the under the same thing here. So since delta S universe will be positive for irreversible